So what is this question? So this question is, friction coefficient between the board and the floor shown in figure is mu. Find the maximum force that the man can exert on the rope so that the ball does not slip on the floor. Okay, so this is a one kind of experiment, and you can find this kind of experiment in the different science cities. So if you go to science city, you may have this kind of devices built there. You can stand on the platform and you can pull the rope. So how much maximum force you are going to apply so that the object is going to move. So this kind of things are there in the science cities. So now we will solve this. So it is saying, find the maximum force that the man can exert on the rope so that board does not slip. Okay, so since there is no separate acceleration for board and the man, we have to just find the critical value of force. Okay, the maximum force we need to find. So no need to write acceleration, just we have to write the balancing equations. So if you consider the man plus plank together, we can consider them together because it is getting pulled on one side and it is getting pulled on the by the string on the upper side. So what we can do is, since they are not moving, they can be taken together. For m plus m together, m plus m together, man plus box together, we can write free body diagram. So free body diagram will be what? First, it's weight. Weight will be m plus capital M G. Okay. Then there will be normal from the ground. Only the external force, the normal between man's feet and the plank will not be written because this is internal now. Between the plank and the man, that force will not be written. The normal which is from the ground, that we have written, that we are writing. So normal is here. Then since the man is pulling the rope, so the man will exert a force in downward direction on the rope, and the rope will exert a force on the man in upward direction. So on the man plank system, there will be upward force of tension. Okay, and this tension will be coming through this string from here also. So on the man plank system, on the man board system, there will be extra tension in rightward direction as well. This one tension. So one tension is rightward, one tension is upward, one is normal, and then we have the gravitational force. And since the whole system is trying to move, there will be a friction force against the motion. So if he pulls the rope, the whole thing, the box man will tend to be pulled in the rightward direction. Therefore, friction will act in the leftward direction. So that we have written. So these are the forces. This is free body diagram for the system. Now, if this is free body diagram, then we can write the equations. So to move, the tension must be greater than friction. So we can start with the balancing equation. So tension must be equal to friction at this maximum force. So tension must be equal to friction, and the friction is how much? Friction is mu times normal. And how much will be normal? So for normal, we will write vertical equation. This is horizontal equation. This is horizontal. Along vertical, we can write T plus normal upward, and downward is small m plus capital M G. That is vertical. Okay. So how much is normal? Normal is small m plus capital M G minus T. So this has to be put in the first equation. So if you put this thing in this equation, we are going to have T equal to mu, and in place of normal, we will have small m plus capital M G minus T. So if we solve, it will be T equal to mu G m plus M, and then minus mu t. So T plus mu t equal to mu g m plus m. So how much is T? That is mu g divided by 1 plus mu m plus m. Okay, so in this way we can find. So this is the tension applied on the string. So this is the maximum tension which we can apply, the maximum force which the man can apply on the string, and the so that the board will not slip. Okay, so this will be the answer. In this way we can find.